Hello everyone, in this video I am going to teach you factoring quadratic equation in the form of ax squared plus bx plus c equals 0, where a, or the leading coefficient, is equal to 1. Okay, so what do we mean by factoring? Factoring basically reverses the multiplication process. Now, there's one thing you need to know when it comes to factoring quadratic function or quadratic equation. Not all quadratic equations are factorable. Okay, now remember that factoring is actually one of the methods in solving quadratic equation, but not all of them are factorable. So the question is, how will we know if a quadratic equation is factorable? So here, what we will do is we need to find the discriminant of that quadratic equation. So if the discriminant is either 0 or a positive perfect square number, then we can conclude that without even trying, by using the discriminant, the quadratic equation is factorable. Again, if the answers if the answer is either exactly equal to 0 or a positive perfect square number, then therefore it's factorable. If not 0, since if it's negative or a positive or a positive number but not a perfect square number, then therefore it's not factorable. So let me just give you two examples here. So which between these two is factorable? We will use the discriminant, right? The discriminant formula. So for this one, our A here is 1, our B is 10, and our C is 25. So this is 10 square minus 4 times A, which is 1. Our C here is 25. This is 100. You see there's only one minus sign. Oh, so I'll put minus sign, and then 4 times 1 times 25 is 100. And that is equal to 0. So therefore, for letter A, okay, that's factorable. Okay, so we can use factoring here. Letter B factorable. So let's identify A, that's negative 2. B is negative 4. C is negative 5. So D is equal to B squared minus 4AC. That's negative 4 squared minus 4 times negative 2 times negative 5. This is 16. There's 3 minus signs, so that's minus 4 times 2 is equal to 8 times 5 is equal to 40, right? 16 minus 40 is negative 24. So since it's negative, therefore letter B is not factorable. Sorry about that. Okay, so it's not factorable. There, not factorable. Okay, so again, let me just repeat this. How will we know if a quadratic equation is factorable? Use the discriminant. If the answer is equal to 0 or a positive perfect square number, it's factorable. If it's not 0 or not a positive perfect square number, therefore it's not factorable. Okay, so let's go now to factoring quadratic equation in the form of ax squared plus bx plus c, where a, the numerical coefficient of the leading term, is equal to 1. So one thing that it's very obvious here is that this quadratic equation, okay, the factors of that are two binomials. Okay, so we will start with the factors of x squared, that's just x and x, and then you're going to look at the constant, that's positive 12, right? It's positive 12. Now the next thing you're going to do here is just to find all the factors of positive 12. I mean, two numbers that when you multiply, the answer is positive 12. So I can say that we can have 12 and 1, right? Negative 12 and negative 1 will do. 4 and 3, that's 12 also. Negative 4 and negative 3, that is 12. 6 and 1, no, that's not 12. Sorry about that. Eraser. 6 and 2. And then negative 6 and negative 2. So all of these combinations, 12, 1, negative 12, negative 1, 4, 3, negative 4, times negative 3, 6, 2, and negative 6, and negative 2. All of them, if we multiply them, they will be equal to 12. Now, we need to select which pair. Okay, which pair will give us a sum of positive 7. So if we add them, the answer should be positive 7, right? 12 plus 1. No. Negative 12 plus negative 1. No. 4 plus 3. Yes. So 4 plus 3 is 7. 4 times 3 is 12. So I will write, it doesn't matter. It can be x plus 3 or x plus 4. These are the factors. Okay. Now, if you check the last three pairs, that's 8, that's negative 8, and that's negative 7. What we want is positive 7. So that's how you figure out the factors of quadratic equation. Let's have the second one. Again, this procedure is basically for a quadratic equation that has in the form of ax squared plus bx plus c, where a is equals 1. Okay, is equal to 1. Look at the constant, positive 2. And then I will think of the numbers, two numbers that when you multiply the answer is positive 2. Okay. That's positive 2. Aside from those two, what do you think? What else? We're looking for integers. Okay, so those are the only two combinations. Which one will give us a sum of negative 3? That's the next step. So it's like a puzzle, right? Two numbers, when you multiply them, the answer is positive 2. Then these two numbers, if you add them, the answer should be negative 3, which is the middle term, the numerical coefficient of the middle term. That's right. So here we're looking at negative 2 and negative 1. We can switch them. It can be x minus 1 times x minus 2. That's the answer. Those are the factors, right? Okay, let's go to the next example. Here, again, we will start with x and x. Now, consider the constant negative 10. Now, think of two numbers. When you multiply them, the answer is negative 10. That's negative 10. That's negative 10, right? 5 times negative 2 is negative 10. Negative 5 times 2 is also negative 10. So you have 4 pairs here. Now, which among these 4 pairs will give us a sum of positive 3 if we add them? Let's try negative 10, 1. That's negative 9. No. 10 and negative 1. That's positive 9. So no. Positive 5 and negative 2. If we add those two, will that be equal to 3? Yes. So that's what we want. Let's try to check the last one. Negative 5 plus 2. That's negative 3. We want positive 3. So no. So this is plus 5, negative 2. Okay. Let's answer the fourth one. So you have x and x, and then consider the c, which is negative 24. Now think about the factors of negative 24. So negative 24 and 1, 24 and negative 1, 6 and negative 4, negative 6 and 4. There's a lot actually. 3, negative 3 and 8, negative 8 and 3, 12 and 2, negative 2, negative 12, and positive 2. So we have 8 pairs here, right? Okay, now which among these 8 pairs will give us a sum of negative 2? If we add these two numbers, it will be equal to negative 2. Let's try the first one, negative 24 and 1. Nope. 24 and negative 1. Nope. 6 and negative 4. Nope. Negative 6 and 4. Will that be equal to negative 2? Yes, that's what we want. We don't need to test this 4. We already found the correct combination, and that's negative 6 and positive 4. That's our answer. Okay? Let's go to the last two examples. Okay? So again, this is a product of two binomials. Okay. Consider the constant negative 14. Find the factors of negative 14. Start at 14, negative 1, negative 14, 1, 7, negative 2, negative 7, positive 2. So we have 4 pairs here. Which one will give us a sum of 5 if we add? Yeah, which one will give us a sum? So that means we will add 14, negative 1. Nope. Negative 14 and 1. Nope. 7 and negative 2. Yes. So that's plus 7, negative 2. So in short, we need to look for these two numbers. If we multiply them, the answer should be the constant. If we add them, the answer should be the numerical coefficient of the second term. Let's try the last one. Okay, that's negative 27. That's negative 27 and 1. 27, negative 1. 9 and negative 3. Negative 9 and positive 3. Okay. So all of those 4 pairs, okay, each and every one of those 4 pairs will give you a product of negative 27, which is here, the constant. Now, the next thing that you got to consider is that if you add those two, the answer should be negative 6. Negative 27 and 1, nope. 27 and negative 1, nope. 9 plus negative 3. Positive 6, we want negative 6, so no. Negative 9 plus 3. That's negative 6, that's what we want. So, negative 9, positive 3. There you go. So that's how you find the factors of quadratic equations in the form of ax squared plus bx plus c, where a equals 1. In the next video that I will be teaching, it's going to be about factoring quadratic equations in the form of ax squared plus bx plus c, where a is not equal to 1. So that's going to be a different method than this one. So thank you for watching.